Dr. Card and you're ready for you to do now. The one, good job, Dr. Card, you're ready for you to do now. Dr. Card should be out on your desk. And get ready for you to do now. Make sure you're dating your do now. Make sure your Dr. Card is on your desk. And remain silent. Show all work. You do not have to write the actual question, but make sure you're showing the work of what you're doing to answer it. Myra.
I didn't get my hot card.
Okay, I can't give you one. So you need to check with the teacher that usually gives it to you. You have to give them your old one and make sure you renew.
I turned it, but I forgot to get the other one.
Check with your teacher. sure you check the timer up there. We got about 1 and 10 seconds left, 1 minute, 10 seconds. Make sure you number them as they are up there, number 4 and number 5, so make sure you number them that way. Seconds. All right. Okay. Number 4. Irene, read that for us.
A restaurant employee keeps track of the number of hours worked in 1 week. If the employee is paid $7,
Hold on, I'll read you. You have to speak up a little bit more.
If the employee is paid $7.15 per hour, how much will the paycheck for this week equal?
Okay. So what did you do to solve this one?
I skipped that one and I went to number 5.
Really? Okay, so looking at it now, read the question again. Just read the question part of it. If the employee, that part, read that again.
If the employee is paid $7.15 per hour, how much will the paycheck for this week equal?
Okay, so she's paid $7.15 per hour. How many hours did she work that week, or whoever this is? How many hours did they work this week?
20.
How many?
28.
28. What did you do to get 28?
I just guessed.
Okay, so instead of guessing, what could we have done?
We could have,
Okay, Oriana wants to help you out.
yeah,
Okay. Did you hear what she said? Okay, say it again.
Out of all the hours and multiply it by $7.15.
What did she say?
She said add all the numbers and add by and multiply it by a number.
Okay, so wait a minute. First, we need to know how many hours she worked. So let's add up all of these numbers or hours that she worked. So how many hours did she work that week, Samuel?
21.
21 hours. So if we added, we would have had 21 hours. So then Oriana said, take that number and multiply, because give them out what it said. She's getting paid $7.15 per hour. No, not for this one, but per hour. So she's getting $7.15 for each hour that she's basically working, right? She's working 21 hours. So what do we do with those numbers? We multiply them together. So $7.15 times 21. So if we multiply those numbers together, what will we get? Ulysses.
I get $150.50.
$150.50? Okay, so he's choosing B, obviously. So thumbs up if we have $150.15. Have that? Now you have that?
Yeah, now I have it.
Okay, so that's 715 times our 121 hours. And you would have had, if we went through it, $150.15. Okay? So what about number 5? Number 5. Naya, read that one out loud for us.
A family lives in a two-story house. The first floor has an area of 550.
Stop, Naya. Alright, so I need everyone tracking Naya. That means we're not doing anything else but either looking at the problem, reading along with her, or we're looking at her. We are tracking only. You don't need that. Okay. Naya only.
A family lives in a two-story house. The first floor has an area of 550 meters squared, and the area of the second floor is 4/5 of the first floor. Which of these options is the total area of the house to the nearest meter?
So what did you do?
Well, I didn't really get to finish, but the one that was more that was really reasonable was A.
Okay. So the first floor has an area of what? Robert,
About 550 meters.
it's telling you right there, the area of the first floor, keep in mind a floor, okay, is 550 square meters, okay? So that means when they multiply their length times their width of this floor, it was 550 square meters, okay? So it says that the second floor is gonna be 4/5 of the first one. So now we gotta figure out what is 4/5 of the first floor. What do we do to find that, Genesis?
Well, you could divide 550 meters by 5, and you
Okay.
get 110,
And then what?
and then from 5, that's what it's going to be.
So just stop there. Kendall, what do we do?
What I did, I got 4/5 and I found a set up a portion, and I did 4/5 and then I did 550 as my denominator. I multiplied it by 110, and I did the same thing to the numerator, and I got 440, and I added those together, and the nearest meter was C.
So you set it up as a proportion like this? Okay. And you had how much?
I multiplied by 110, the denominator and the numerator, and I got 440.
Okay, so his X became 440, okay, which is the area of the second floor. But what's the question? What is the question asking? Did you stop there?
You know,
Okay, so continue.
I added 440 plus 550
Now, why did you add these two together?
because it was asking for the total, and 4/5 is, 440 is representing 4/5 of the second floor.
Okay, excellent. So he has 990 square meters because he adding those two floors together. So you didn't necessarily have to go through this. You could have just said 4/5 of this 550, meaning you're multiplying this fraction times this number, okay? When we say we are multiplying 4/5 times this 550. And you can put it over one just to make it a fraction, okay? You know how to simplify, right? Simplify each one by 5, this becomes 110. 4 times our 110 gives us our 440. 1 times 1, we don't need that. So 440 was that second floor. Katia,
Didn't he say pick C though?
did you say C?
Oh, no, yeah.
Okay, so it's supposed to be B, right. So adding them together, 990. John,
I did mine a different way. I did 550 divided by 5 since it was the denominator was 5.
okay,
So then since it was 110, I times it by 4 and I added both of them.
same way, yep. So that's basically what our simplifying is actually doing, just like that. Yep, you're right. All right, any questions? So make sure these are in our notes. Again, if you do not have it, you make sure you write it. Okay. All right, let's go ahead and set our notes up for today. So what we're doing, we're solving equations. So basically it's gonna be 1 step, 2 step, and we may get to the actual multi-step. Okay? 1 step, 2 step, and multi-step. So keep it short. We're solving equations. Solving equations. We'll be using models, and we're also gonna be working algebraically. So make sure you date it. They say it's 8, November 8th. Now, raise your hand if you can tell me what do you notice about this picture here? What is going on in this picture? Raising hands only. No shout outs. All right, let's start with Sydney.
Well, I see in this picture a person on a bench, but the chair only has the back legs and they're balancing on the bench.
Okay, he's balancing on the bench. Anyone else? You see anything else? Katia?
I see a school.
A school, okay, a school in the background. Robert?
Oh, and,
Not Robert, Martin, sorry.
he's working on something.
Okay, he's working on something, but I like what Sydney said. She said he's balancing himself in this chair on this bench, okay? So that's what we're gonna be trying to do today. We're gonna be balancing equations.
Oh,
No, not on a chair. Okay, so let's get started. So looking at this equation here, we have 3 equal to 2. First off,
This is 3 equal to 3.
I'm sorry, what did I say?
3 equal to 2.
Okay, 3 equals to 3, okay? So, is this an equation?
Yes.
Yes. Are the 2 sides equal?
Yes.
Yes, okay. So what if I did this? What if I added a 2 to this side, my left-hand side? What would that do to my equation now? Unira only.
The equation will be unequal.
Okay, she said it will be unequal. What's on my left-hand side now? 5, and is 5 equal to 3?
No.
No. So what could I do to make them equal to each other again? What could I do to make them equal to each other again? Leslie.
You could,
So right now they're not equal to each other. So put my little.
add
Simple.
another 2 to 3.
Okay, she says maybe add a 2 to this 3. Okay, if I did that, I will have 5 on the left equal to 5 on the right. So are they now equal?
Yes.
So what did we just do to both sides then? Virginia, if you know what we just did. Alyssa.
We add 2 to both sides again.
To keep it balanced, she said we added 2 to both of the sides. That's the only way that they will stay the same is if you do the same thing to both sides. So if I want to subtract something, I can't just do it to one side because as you saw, it wasn't going to stay equal. Okay? So that's how we're going to start balancing our equations. Okay? We gotta move, You have a question? Okay, let's move. So we gotta actually skip that because it's not gonna work. So I want you to write this first one in your notes, and we're gonna be using models to show it. So first thing is write the equation in your notes. Yes, I know it's a simple equation, but we're gonna show models. We're gonna use models to actually solve it. So there are, listen up. There are algebra tiles that are sitting in the baskets in the center of the table. Yes, you need a pack, but listen up. You don't need to be throwing these around. We're not going to be playing with all these pieces, okay? Let me tell you this. These pieces here, we're not going to use, so these can actually stay in the bag because these represent x squared and x squared like this. And we're not dealing with x squared terms right now, okay? So we don't need these. Think about a square, x squared, all right? So what we will use, yeah, you need those. You will use these. These are going to represent our variable x or whatever variable we choose to use, okay? So we have 2 sides to it. So what do you think the green side is going to represent? Robert. Not Robert, Martin. Martin, what's the green going to represent?
Positive.
Positive x, whereas the red's going to represent negative x. So we're going to use those. And we're also going to use the little squares. See these? The very small ones?
Yes.
Can you see it? Okay. So we have yellow and we also have the side red. What do you think they're very small. What do you think the yellow represents? What do you think this is going to represent? Positive 1, and the red's going to represent negative 1. Okay? That's all we need right now. Did you find it? Okay. All right, so have those out. Now, I want you to also do this. So you can use your notebook as your base, okay, or as you're gonna model it, okay? So draw a line down the equal sign to show that, hey, I have two sides of my equal sign, okay? Now, we're gonna use models to represent it. Here's my rectangle, so this is gonna be my x, and it says x plus 2, so that means I need 2 yellow ones. Here's my 2 yellow ones, okay? So that's my x plus 2 equal to what? 5. So that means I need 5 positive ones. So 1, 2, 3, 4, and 5.
You lost me.
Okay, so someone says he's lost. All right, so listen up. So once again, you have two sides of our equals, okay? It's an equation, so that means you will have two sides of it, right? On our left-hand side of the equal sign, all eyes up here. You say you don't understand, so you need to listen. Okay, look up here. On this left-hand side, we have x plus 2. That's an x, that's a variable. It's representing a number, we just don't know what it is right now. We can figure it out without using the models, but we're going to use models right now, okay? So here's my x. I'm adding a 2. So an x and a 2 are two different things right now, okay? X is a variable, this is a number, okay? So that's why they're represented with two different things. This is a positive 2 that sits here, so I'm using the yellow side, okay? So you need to have yours on yellow, right? Equal to. So here separates my side. On my right side, there's just a number. It's a positive 5. So I'm just going to put positive 5 or 5 of these yellow squares. So that's it. So we look at this, we're using a model to represent it. Listen. Okay, so now we look at it and say, or we look for what is alike on the two sides. So what do you notice? On the two sides of this equation, that's the same thing. Jonathan, what do you see that's the same?
They're both positive,
Okay, we have something positive. What do you mean by that?
like the 2 and then the 3 are both positive.
What three? I'm secret.
I mean the 5 sorry.
Okay, so he said there's a positive 2 and there's a positive 5, meaning we see some yellow squares, right?
Yep.
So think about this. If I wanted to get this variable by itself, because that's what we do when we solve equations, we always want to isolate our variable. We want to get it by itself. What needs to go away? Okay? What needs to be moved so we can have just that x, which is the green rectangle, by itself, sitting?
We need to move the 2.
We need to move the 2, so how can we do that? So remember, think about the 3 equal to 3. What were we doing to keep it balanced? Alyssa?
We have to add 2
Okay, but here, what do we need to do? Because I want this by itself. Leslie?
You could subtract your 2 positives.
Okay, so you're saying from both sides or one side? Remember, I can't do something to one and not the other. We have to do it to both. She's right. So if I take away 2 here, then I have to do the same thing here because I'm trying to keep my equation balanced. Remember that? So to keep it balanced, do the exact same thing to both sides. I've isolated my variable. It's by itself now. What is it equal to? 3. So I can say x equals 3. Now check it though. Hold on. Let's check to see if this is a true statement. So if that is the case, if I were to replace my x with that number that I said it is, 3 plus 2, is this equal to 5?
No.
Yes. It is. Is it not equal to 5?
That's so crazy.
Yes. So we know that, yes, our x is equal to 3. It's 3. So we solved our equation. Okay? All right, let's try another. So let me tell you this as well. There are different ways you can model equations, and there are different symbols that people use to model. Here, they're using a cup to represent their variable x. Okay? They're using these gray circles to represent their positive numbers. So there are many different ways that you will see equations being modeled, and that's how it's going to be tested. So this is why we're modeling it right now, okay? Because that's what you're gonna see on the test. So what they're gonna do to solve it, basically they wanna know how many can fit in this cup that's gonna make these two sides the same. So what they're doing is, hey, to solve this, I need to get rid of something, okay? To isolate this cup or this variable x, we need to get rid of something. They circled what they need to get rid of. And then look, here's the cup by itself. What is it equal to? 33. Just like we did, okay? So different ways to model. Let's try another one. So writing this in your notes. So pretty similar. And we're gonna model this one as well. So now it's x plus 4. So now I need 4 yellows and 5 yellows on the right side. Okay? So now we have x plus 4 equals to 5. So thinking about it again, what do you need to do to solve it? Meaning get those, or get that variable by itself. I want to make sure everybody has it. You should have your model. Yep. All right. You ready? All right, Joseph, tell us what we need to do to isolate our variable. What can we do? Okay, okay, or if we're modeling, what do we do to both sides? Okay, how? Would you want to add something to it? Why? What would you add? One yellow? To both sides?
No.
Remember, this is an equation, so I can't add one to this side and not the other. What do we do? Remember, listen, again, what are we trying to get by itself? Joseph, the variable. Which one represents your variable? Out of all this that's up here, what is representing our variable? Which one is the x? The green rectangle, right? So if I want this by itself, what's keeping me from having this by itself? What do you see that's over on that side with it? The 4 1s, right? So can we get rid of them some kind of way? How? Taking them away. So can I take away 4 from here and here? We have enough to do that, right? Yeah. So let's do it. 4 and 4, we're removing them, they're gone. We got our variable by itself. What is it equal to?
1.
Does that solve your equation?
Yes.
Because if you replaced that x with a 1, add 4 to it, does it give us our 5? Yes. So yes, we're good. This is our solution. Okay? So our solution is 1 because it's the number that makes your equation true. Okay? Do we see that?
Yes.
So we're doing the same thing to both sides. Okay, so let's try another one. So here they're showing you again. All right, this one. What if we had something that included negative numbers? Now this one we're not going to model because this number may be large. I want us to, listen up. We're not going to model this one. We're going to use algebraic. Okay? So I want us to see how it works algebraically. So writing this one in our notes. R plus 16 equals negative 7. So putting those to the side, let's actually try this without the models. So thinking about isolating your variable, meaning get it by itself, what needs to go? Genesis.
The 16.
The 16. So if it's a positive 16 or a plus 16, what do you think we can do to get rid of it? All right, Miss Irene, what do you think we should do to get rid of it?
We should add
Add what? Get our line there.
We should add the R, the.
Okay, so Irene, once again, we want to isolate the variable. We want the R to be on that side by itself. So what's keeping us from having this R on the left by itself? That positive 16. So think about what is the only way we can get rid of this positive 16. If you had to model it, you would have 16 yellows, correct? Okay, so how can you get rid of all these yellow squares? Leslie, subtract 16 from both sides. Excellent. We're going to subtract 16 from both sides. Look at that. This is working it algebraically. We always usually go vertically. Okay? Sometimes you see them horizontally, but I like to go vertically. So we're subtracting. I need you writing this.
Wow.
So if I, listen now, so look at this clearly. I have an R here plus 16. But what I'm doing is I'm subtracting 16 from the 16. So if this is a positive 16, and if I subtract 16 from it, what do we get? 0. That's how you can get rid of something. So if that is gone, guess what? My variable is by itself now. Equal to what now? So look, this is a negative 7 minus 16. Negative 7 minus 16. Sydney.
Negative 23.
Negative 23. Now, how did you know that?
I already did it.
She's a 90s college.
Okay, she already did it. So sometimes, listen, remember when we were dealing with our integers, okay? And we had to subtract integers. What was the rule that we used to help us? Raise your hand if you remember the rule. Raising hand only. Martin, what was that rule?
I think, I'm not sure if this is the one for subtraction or addition, but like, you keep the sign of the biggest number.
That wasn't it. Katia, what's that rule?
Keep change.
Keep, change. We're going to keep, listen up, we're going to keep the first one. We change our sign to addition, and we get the opposite of this number. So change it to its opposite. So this is keep, change. Now we're adding two negative numbers. That's why it's a negative 23. Okay? So look at it this way. Hey, I see two negative numbers. Then in your mind you should know, hey, I know I got to add these because of this rule. Okay? So we add two negative numbers. Done. So let's check it and make sure though. So if we have to check it, we always replace the variable with the number that we set. We said it's negative 23, so I'm going to put negative 23 in its place. Add 16. Does it equal to a negative 7?
Yep.
So think about the rule for adding integers now. How do we add integers? Subtract, keep the sign of the
Larger.
there it is. So if we subtracted 23 and 16, we would get a 7,
Yes.
but we would have to take on this negative.
Yeah.
Okay? So it is negative 7. So done. This is our solution. Okay? Some of y'all still looking confused?
This is easy.
Good? Good so far? Yeah. All right, that's what I want to hear. So this is how they were modeling, same way. They call it a river, the line that we draw, because it just separates your two sides. Does it have to be blue? That doesn't matter right now. So we're subtracting 16 from both sides, just like we did here. So as you can see, it's always lined up what you're subtracting it from. So we're not subtracting it from our variable, but we're subtracting it from our number. Okay? Make sure you do that. And you really can't see it, but it's R equal to negative 23.
Oh, man, you see it.
Sure? No. Alright. You will. Just hold on. So for this one, I want us to model it. We're back to modeling. Now, x minus 4 equals 2. Again, we're drawing that river, okay, that line down the equal sign. Separate your sides. X. Now, this one says minus 4. So what color do you think you should be using here? Red. Let's get some red squares. Because we're subtracting 4, okay? We're subtracting, we could look at, what if this wasn't there? What would you see?
So it's only.
You would see it as a -4, so it could be. So remember that. That's why we're using the red color. Hold on. What's on this side? 2. Those are positive. So now look at it. So modeling it, you always gotta look for what is the same, because if it's the same, we can just remove them. But do we see anything that's alike on ours?
No.
So if that's the case, what can we do to remove something on this? Keep in mind, what are we always trying to do? What's our whole purpose? Isolate the variable. So we want to get that green rectangle by itself. Okay, so what can we do? Come on, Robert.
Take off the square.
How? I can't remove them because remember, there's nothing alike on both sides. So what can we do in this case? Hold on.
Take off only,
Okay, let's Alyssa, let's see what Alyssa's gonna tell us.
Since it's a negative, to make it 0 and to make the variable by itself, you have to
Hold on,
add.
Alyssa. All right, so everyone is tracking Alyssa. That means you're silent and you're listening.
Since it's a negative and you trim the variable by itself, to make it 0, you have to add 4.
Add for what?
4 positive.
Let's do that. We're gonna add for positives because that's the only way we can remove some negatives. So remember when we were dealing with those counters, okay, when we were trying to add and subtract those integers, these become, a red and a yellow together makes what? Red and yellow makes what? Alyssa, red and yellow makes what? Red and yellow makes? 0. 0, our 0 pair, remember that? So we have 4 red, we have 4 yellow, all of these are gone because that becomes 0. That's a -4 plus 4, that's 0. Okay, again, let's go back. What are these representing, you guys? -4. So a -4 plus 4, isn't that 0?
Yes.
Don't they cancel each other? Yeah. All right, gone. So what do we have our variable left? What is it equal to?
6.
X equals 6. So let's check it. So if we were to replace our variable with that number that we said our X is now, 6 minus 4, what does that give us? 2. It does give us that other side, so we know we're good to go. Okay? Correct. This is our solution. It made our equation true. That's what you're looking for. Okay? Genesis,
So you can just basically do the opposite of what the equation is telling you to do.
did y'all hear that?
Yes.
All right, say it again, Genesis, because I need to hear it, so hold on. If you're not listening, you will miss it. So we're tracking Miss Genesis so we can actually hear and understand what she just said. Ready, Leslie?
Yes.
All right.
So basically all you do is just do the opposite of what the equation is telling you to do.
Okay, so for our case, because we said, we saw subtraction, she said do the opposite. What's the opposite of subtraction?
Addition.
We added those 4 ones to that side. We added those 4 ones to the other side. So you definitely have to make sure you're doing it to both. And it's going to be basically that opposite operation or inverse operation. And it always basically what? It leaves your variable. That's what you're always trying to do. Isolate it. Get it by itself. Okay? Let's try another one. So they're showing you here that the black ones were representing the negative, and then the gray ones represent the positive, so they did it to both sides. And yes, the X equals to positive 6, just like what we had. All right, here's another one. We're not going to use the models for this one because that number's kind of large. So So let's just use our algebraic way. So you need to be able to see both ways. And just like Genesis told us, all we have to do is do the inverse, we will get it. So R minus 7 equals to a negative 16. So what is the inverse operation? We're gonna add what? Let's add 7. So I'm adding 7 to both of our sides. So now we gotta figure out what is this equal to. Ruel, go. R equals to a negative 27.
Oh, no.
Okay, right here, this a negative 7 plus 7 is gonna always give us 0. So the negative and they're the opposites of each other. Okay, that's always gonna be 0. So gone. We're looking for the other side. Remember, if you're doing the opposite operation and this exact same number, it's gonna get rid of itself. It's similar. It's similar. Jose, what do we have now? Negative 16 plus 7 is? Maybe write it to the side, I don't know. Would this help?
23.
Negative. No. Negative 16 plus 7. Adding with different signs. Ulysses. Negative 9. Negative 9. Because we're adding with different signs. We subtract and we take the sign of the larger number. Okay? Or the larger absolute value. So if you have to check it, remember, always check. We replace our R with a negative 9 minus 7. Does it give us this negative 16?
Yes.
How do you know? Can we rewrite it to that addition form, Samuel?
Yes.
How did that look?
Negative 9 plus negative 7.
Excellent. We're adding its opposite, so definitely adding to negative. We got it. We got it. So make sure you always check, because hey, we can always make a mistake here and there. So checking it will hopefully help. Are we clear so far?
Yes, ma'am.
All right. So here, another one step. Another one step. Now this one here with the model, it's small. Oh, sorry. Negative 9 minus 7. And set it equal to the negative 16. All right, Miss Noor,
I have a question.
go.
Could you, like, do we always have to do the algebraic way or the pattern way?
What?
Or can we just do it like,
Just guess.
no guess, but like in your head, you know?
I know,
Like 6
yeah, for
letters.
these, yeah, listen, I know these are pretty simple, but what I'm trying to show you is the process, okay? So when they do get larger and a little more difficult, you know the process of getting to that answer, if you can't just guess it. I know, this is easy, yeah, definitely you should know that right off, okay? So these are probably not, you're probably not gonna see these on the test, because yeah, these are just simple, okay? So that I will show you the ones that you will actually see. So they take a little more work. Okay, so let's make sure we understand the process. So when we see something like that again, that includes this, we know what to do. Okay? Alright, so it is lunchtime, so we're gonna stop here. Hold on. Hold on. So leave your algebra tiles on the desk. Don't move those. Grab your agendas and your hocker cards and your lunch. Remain silent. And we're going to line up silent. Let's go. You got 30 seconds. Let's go. Remaining silent. 20 seconds. 15 seconds. 10, 9, 7.6. Awesome. And you're silent. Thank you for remaining silent. We're lining up silently out here as well. New record, you're right.
Unless you want to sit in my room, you can.
Anytime you see a fraction, yes, it is division, okay? So that's our fraction bar again. So we know this number is being divided by 4 and it needs to equal up to 7. So again, if we are trying to isolate our variable, we're gonna do the inverse of division. Yamna, what do we need to do for this one?
Multiply 4.
We need to multiply both sides by 4. So I'm gonna rewrite it again. And we're gonna multiply this side by 4, that's on the left. And we're gonna multiply this side also by 4. So this gets rid of each other, okay? Remember when we were doing our little simplification? Becomes 1, that's what we're trying to do. So now our variable is left. X equals what? Alyssa. 28. 28. Now let's check that. We multiplied both sides by 4 because we wanted to get rid of the denominator of 4. So think about it, or maybe if you want to look at it this way. If we make both fractions, that's a 4 times an x, that's just 4x, over 1 times 4, which is just 4. But we can always simplify this because these are the same number. So think about that as 4 divided by 4, that just becomes a 1x. Okay? And you don't have to write the 1. Because it's understood. How many x's do we see?
1.
1.
Uno.
So, there it is. So again, you can't do something to one side and not the other. Keep it balanced. So with 7 times 4, that's where the 28 comes from. But again, let's check it. If I replace the x with 28 and divided it by 4, does it give us 7?
Yes.
We know we're right. Done. Okay? So this is showing the work. We showed that we were multiplying by 4 on both sides. Okay? So any division problem, you show that you're multiplying both sides by the denominator, okay? And that will give you your x. So you don't believe it's 28? You could have guessed this, okay? Keep in mind, these are the one step where you can truly guess it. Okay? What number can I divide by 4 that's going to give you 7? Doesn't it make sense that, yeah, just multiply them, it's the opposite of division.
Also, we just.
Wait, hold on. Martin, what's your question again?
So, like that's the division, do we do the opposite, multiply, and then we subtract, and then we just do addition and vice versa?
Correct. It's always your inverse operation that you use to get your variable by itself. Yes, always. Always, okay? And make sure you're just showing that you're doing it to both sides because it's an equation. All right? Even though I know, hey, I can see these are only two numbers that's up here. Of course, just multiply them together. Okay? Your turn. Your turn. All right, we're silent. So, t divided by 3 equals to 5. So again, I want you to show what you're doing to both sides because again, these are your notes. I know you understand. Just go ahead and quickly show it. It's like 1 or 2 seconds you writing that. It's coming. Shh. It's coming. You want some challenging problems? Here they come. Let's go. We're ready. Move on. Next thing. Just make sure you keep the date. Ready? Gotta show. Awesome. She's ready. Pocket cards back out on your desk. Okay, so keep this in mind. You are not talking at this time. Let's be clear on that. Martin, are we clear? Okay. Let's turn our voices off unless I tell you to talk to your neighbor. And I have not said that yet. All right, so real quick, now you can talk to your neighbor. Quickly share what you did to solve this particular problem here. 30 seconds, go.
Hey, what I did. I multiplied both sides by 3. And I got the variable on I just multiplied 3 on each side. And then I got
Five, 4, 3, 2, and 1. Good job. Good job. Now, who's going to share out for us? Raise your hand if you want to share what y'all talked about. All right, let's go with Kendall.
He said that we multiply by 3 on each side.
Okay. So multiplying 3 here. Multiplying this side by 3 here.
And cross that with 3, and it was a t, so like 1t.
Okay.
It goes to 15 because 5 times 3 is 15.
Okay, and let's check it. So replacing the t with the number that he said. So 15 divided by 3 equals to 5. Is this a true statement?
Yes.
Yes, it is. So, good to go. T is 15. Thumbs up if you had t equal to 15. Good. All right. Now, get in a little bit. So look at the difference here, and we're going to model this one, okay? So instead of algebraically, we want to model the first one. 2x, make sure this is in your notes, plus 3 equals 6. Let's draw our bar there, or our river, whatever you want to call it. So we're separating our two sides. So we have 2x, put our x's, and we have plus 3, so that's a positive 3, and we have positive 6 on the other side. So now, again, looking for what's alike in this, what do we notice that's on the same side? Or on the two different sides? What do we see that's the same? Raise your hand if you can see something that's alike on both sides. Jonathan, what do you notice?
They're both positive?
All right, we have both positive numbers. What else do we see? What else do we see? Irene, what do you notice?
That
Keep in mind, the bar is separating our two sides. So what do you see that's the same on the two sides of it, the left and right?
what's the same?
Yes. What do you see that looks the same?
It has yellow squares.
They both have yellow squares, true, which are the positive numbers. So how many are on the left side?
3,
3. How many on the right?
6.
Okay, so think about if we're trying to isolate our variable, we want to get these by itself. What can go away?
The 3 squares divided by
We can take away 3 squares? Can we do that to both sides?
Yes.
Can we, Irene? Yes, we can, because we have enough to do that. So if I take away, what am I actually doing? Subtracting 3 from both sides. Okay, so now we have 2x equal to 3. So what do we do now? So now we're trying to figure out what one of these x's will equal to. We know what 2 equal to, but now let's figure out what 1 will equal to. Jose, what do you have?
We divide 2 on both sides.
Okay, he says to divide, meaning groups. We're trying to get some groups up, right?
Yes.
How many can fit into each of these groups? This x and this x. So how many can fit in each group? Just one?
Yeah.
We can get one in this group, we get one in this one. What about the one that's left over? What am I gonna do with it?
Me? Putting a decimal?
Okay. What does that mean?
Oh. Since only 1 goes in.
One full one.
Yeah, 1 full
Okay.
one.
What do we do with this one that's left over?
Divide 2 and 1 make it 0.5.
Okay, or half, right. So if I divided this thing in half, I could put a half in this one, and I could have put a half in this one, right? So what does that actually tell you your x is? You narrow,
1.5.
1.5, right? So let's look at it algebraically. So if we're subtracting the 3, that's what we did when we removed our 3 squares here. We're subtracting 3 from both sides. That gets rid of the 3 that's on the left-hand side. We have our 2x equal to, what's 6 minus 3? That gave us our 3. But at this point, he said, we need to divide because what is this operation that's going on the left? They were being multiplied, so definitely we do our opposite or our inverse. So 2 divided by 2 makes 1, x equal to this 3 divided by 2, and we can say or put it in our mixed number form, that's our 1.5. Okay, and what you saw in the model. So our x is 1.5. So sometimes you will get fractions as your answers or your solutions. So just know that it's possible. Good? Was that clear?
Yeah.
A little bit? Need another example? Next. Let's try another one then. All right, here's our work. So you can model it or you can use the algebraic method on this one. I'm letting you choose. 3x minus 2 equal to 1. So as you can see, there's really nothing that's the same on both sides of the equation. So now we got to figure out, okay, if we still want to get these by itself, how can we get rid of those? So the only way, excellent.
I do it here, I have to do it here. Right? Okay, so that gets rid of. So you are left with your variables equal to this. But now think about, okay, how can I get just one of these x's? Or kind of maybe how many can fit in these x? Only one here. So obviously that is one. And then you can change it. Minus 2. Done. That's model. You just model it first. Did you write in your notes? So you just guess it? Because I don't see any concept. 5, 4, 3, 2, and 1. So for this particular problem, think about how many steps it took you to get to your solution. How many steps did it take you to get to your solution? It only took one step?
2.
You did one thing and you had what x was equal to? Yes or no?
No.
No. How many steps did it take us?
4.
Took you 4? Wow.
1.
Okay, let's look at that. So we're going to look at this one algebraically as well. 3x minus 2. Do we need to see the model?
No.
Yes? Okay, let's see that.
Oh.
We'll do both. It's okay. It won't take long. 3x. We're silent, you guys. Minus 2 equal to 1. Okay? So obviously when you look at this, there's nothing alike. We got these green things, red things, yellow things, nothing's alike. Right?
Yeah.
So the thing what we're always trying to do is get to the point where we have x equal to some number, right? So we want these by themselves, all right? That's our starting point, to get these by themselves. Now, what is the way that we can do that if we have these negatives up here and we just can't remove them? Can't just subtract them off. So what do? Nora?
You have to add.
Add what? Add 2 positives?
Yes.
Okay, great. So if I add 2 positives, and I gotta do it to the other side as well, these can be removed because remember, they're the negative, the 0 pairs. So we can remove those. So what do we have now? So if we saw that, we have 3 x's equal to 3. Right. So at that step, now, think about it. What operation is going on this side? Multiplication. So now we gotta divide. So mainly we're looking at how many groups of. Okay? So think about it. What can be in each group? Okay? Correct. X equals 1. Because there's only one that can fit in each group of those x's. Okay? So yes. And check yourself. What's 3 times 1? 3. Minus 2. 3 minus 2 is 1. So it works. So our solution is 1. This is the number that makes it true. How's that one? Not too bad. Actually, we're getting into the even longer ones. Hold on. What do you mean? To go through the whole thing? Okay. Alright, let's go back. Just gonna move those out the way. So to see it algebraically, first step, remember, let's get rid of the number. You don't work with the variable yet. Get rid of the number. Okay? So we added 2. That's when we saw adding the 2 positives. That's what we're doing as well. Those 2 obviously will cancel each other out. 3x is left on that side, and this becomes 3. So remember, if you're doing it to both sides, you still are equivalent. Just know that even though it could have been the wrong thing to do, it still would be equivalent because you're doing the same thing. Okay? So for us, we always want to keep it simple and try to isolate the variables. And we're getting there. So one more step and we will have it. If we divide by 3 and divide by 3 here, we can get our x by itself. Do you see that? So 3 divided by 3 gave us what? The 1. Well, you just missed it? Just left us that way. These were the steps. So it's first step, adding 2 to both sides. Why we chose 2? Why are we not adding 1? Raise your hand if you understand. Why are we adding 2 to both sides? Why not add any other number? Why 2? Yumna.
Oh, because there's 2 in the equation.
Because of this 2 here, why not add 1? Ulysses,
Because you're trying to isolate the variable.
say it again.
Because you're trying to isolate the variable.
Yes, we're trying to isolate the variable. When we say isolate, that means you're trying to get yourself by yourself, isolate, okay? So we want it by itself. To get this by itself, get rid of that, okay? So that's why we use that number instead of any other number, okay? All right, good. All right, here's the other one.
Oh, that was big.
Let's model this. We're modeling. Let's model. So 4x plus 1 equals 2x plus 7. We need 4 x's. We need 2 x's on the other side. We need positive 1 on this side, and we need 7 over here. All right, so we have 4x plus 1 equals 2x plus 7. So again, when you're looking at models, you look, hey, is there something the same on both sides? So I see something actually. Oriana, what do you notice? She said, can we take away the 2 greens?
Yes?
Yes. So taking away the 2 greens means we're doing what? We're subtracting 2 x's from both sides. Ah, good. We're narrowing this thing down. Now what? Do we notice anything else the same? Yes. Oriana's ready today. You guys see anything else? Yes. Liz.
Still, a positive on,
Okay, so what can we do?
that way.
Just this one?
On both sides.
All right, she said we can subtract 1 or take away 1 from both sides. We can do that because they were the same. Anything else? Anything else? So nothing looks alike anymore, right? So at this step, now what? Now what? What do we do now? So we have 2x equal to 6.
Wait.
2x equal to 6. You know, what do we do?
We divide 2.
Let's get some groups. Yes, let's get some groups. How many can go in this x? How many can go in this one? 3. X equals 3. 3. These 3 can go here, and these 3 can go with that one. So obviously our x is 3.
It looks hard, but it's easy.
Right, it looks hard, but it's really actually easy. You're right. It looks like a lot of stuff going on, but it's not. Okay? So now I want us to actually see this. Well, let's check it first. What's 4 times 3?
12.
Plus 1.
13.
What's 2 times 3?
6.
Plus 7.
13.
So it checks out. It checks out. It is. It better be. If you solving it, it better be. Okay?
You get another.
You do have another. But hold on. Let me show you this way as well. I know this is long, but keep in mind, this is how it's actually going to be modeled. You see a lot of these on the test. You see a lot of these on the test. Okay? And they will show you the model. Sometimes they give you the equation and model. And then you have to choose either what step comes first or what's the solution. Okay? So, algebraically, you have actually 2 options. Oriana told us to get rid of those X's first. You could have, or you could have even worked with the numbers first. So it's actually options on this part. So we'll do what she said, we'll get rid of the 2X. We can do that, okay? Because it's fine, you can do that. 4X minus 2X gives us 2X. As you can see, we didn't do anything with this, so I'm bringing it down. Equal to, I'll have to draw our line. We got rid of the 2X, but our 7 is, positive 7 is left. You guys see that?
Yes.
So now at this step, we do what? Again, we're trying to isolate this, so let's get rid of this. Let's subtract the 1. We did that next, didn't we? Subtracting the 1s, so that gets rid of it. 2X equals 6, and then last step we did what? Look at that. So X equals 3. So that's showing it algebraically. You want a model first? You like a model? And if you're doing it with the actual model, the model probably will be quicker actually. But that's if you have the model. It's kind of hard to model the division. Those are kind of tricky. So I wouldn't suggest always using models because some, especially with division, it's kind of hard to show it.
What if it's like this when it's,
Or you can do what we just did, get rid of it. Use it. Five, 4, 3, 2, 1. First thing is you should have this in your notes. That's first thing. Write it. They're using the variable z, which we can keep in mind that doesn't matter. Okay? Remember, the variable does not matter. Okay? It only represents this number. Process is still similar to this, but just make sure you understand what numbers are you dealing with here. Okay? Let's try this one.
Okay.
So now we have 4x. That's all.
You have to combine the terms from the inside out. So if this is positive, then you subtract it. You give it a like.
Oh, wait.
What will you do? Let's say that they want to do that, then what about
You can divide
4Z. Why not? You have 4Z. Are they the same? Look, are they the same? 1, 2, 3, 4. This one. 1, 2, 3. Esas dos se cancelan y pues okay. So you can. So then the new equation will be 3Z minus 2. And then this one. And then you have to isolate that one. That's what I was telling you, why did you have 80 words?
All right, listen up. Let's go ahead and turn our voices back off. So again, if you are modeling, you can draw the models that you like. That helps as well, just to kind of show yourself. So you'll have them at home. You can do this. You can draw you 4 rectangles. These represent your X's. And put X's in them so you'll know that. If you're drawing it. Okay? We have +1. No. Babu. Sister Roll. For Z -1. 2 minus 2. Sorry. And Z -4. So that would be. Okay. So 2 negatives on this side. Z here. So these are Z's. And then -4 here, so we're going to have 4 negatives over here as well. Okay? So that's a -2. Remember, that wasn't there. It's understood to be a negative number. So kind of think of it that way. So now we want to look for what is the same. So what do we notice that's the same? Oriana, what do we notice that's the same? Sure. All right, let's listen up.
You guys know it's hard for me to collect your Hawker cards in the morning because we're in PE, but is there anybody that needs to turn in a Hawker card that did not turn in a Hawker card? Cindy, okay, what about Serta and
I
Cannon?
need it, I didn't get it for me either.
Check.
Raise your hand. Somebody said they didn't bring
Brenda's
it.
still not
I didn't
here.
get it, no, she said,
So
but she
she's
said who didn't return it.
right. So some did not receive a Hawker card either. So
I told you guys to pick your new Hawker card up on the windowsill.
Oh, okay, so they didn't want to listen. Okay.
I wasn't there. I was getting it.
Right, so do you have your Hawker card? And I will come back and bring them some.
Okay. All right. So Oriana, what looks alike on both sides? They both have Z. So if we wanted to remove anything, what would we remove? Okay. She said we can remove 1 Z from each side. So you can just cross it out. Okay. What else? Alyssa, what else could we do?
We can also add 2 to get this side of the variables isolated.
You could, or even just looking at it. Do you see anything alike? Okay, Kendall. We could actually just take away 2 negatives in this case because they're alike on both sides. So I can do this. So now let's kind of just look at what we have left over. We have how many Z's equal to what? 2, ooh, look at that, 2 negatives. So 3 Z's equal to 2 negatives. Now what do we do at this point? So think about now we're getting to how many groups or how many can fit into each Z. So we only have 2. So now we got to figure out how many can fit into each Z.
1 plus 5. No,
1 get into each.
No, never mind.
All right, so let's write it out. 3Z equals -2. Let's look at it this way, okay? Since the model is. So if we had to isolate our variable Z, what would we do? Yanira, divide by what? Let's divide by 3. So this isolates the Z, and it equals to -2 thirds. So that means 2/3, 2/3, and 2/3 can go into each of those Z's. Ah, y'all didn't know you could get negative fractions? No. Yes. Yes, you can. Yes, you can. It's negative because that 2, we're divided by something positive, so it's still negative, right?
It's
For this particular one, yeah, it's kind of hard to really model 2/3 or something. I mean, you could, but let's just take it here. all right? You could cut them, yeah, you could cut them up, but again, it's kind of hard to draw it out, okay? Algebraically, this was part of it, that's the last part of it, but algebraically, if you want to start it,
How would you?
two ways, remember, there's two ways you can start. You can start off with getting rid of maybe a variable first, or you can even start with your numbers. So it's really a choice for you. Let's take it the other way. Let's get rid of our numbers first. So if I want to remove this, I'm going to do the opposite or inverse of subtraction. We're going to add it. But as you can see, I'm adding to the other number. Negative 2 plus 2, that is 0. 4z is left, equal. Let's go ahead and draw a line so we can see the two sides. We have a z left over here, and a negative 4 plus 2, negative 2. So we're still not done because we have z's on two different sides. We don't want that. We always want them on one side together, right? So how can I basically remove that one from that side? Let's subtract a z from both sides, okay? So I'm subtracting it here. That's gone. We have our negative 2 left. If I subtract the z from here, we have 3z. So you see where it comes now? Okay? Now divided by 3. 3 divided by 3 gives us 1z. And this, obviously, you can either change it to decimal if you wanted to, but I will leave it. Negative 2/3. It's already reduced. We're good. Okay? That is it. That's all we can do. Z equals this. So you can check it. You can check it. It is, listen, if you read it, it is z minus 4. But what I'm saying, when we're modeling it to represent that number, think about as if that z wasn't there. What should we put on that side? So instead of putting those positive squares, we need to put the negative squares. Because if this is not there, this number will end up being negative. Okay? So you got to kind of look at it that way. All right? But if we read it, I would say z minus 4. I would. So you want to check it?
Yes.
On this one, let's see, 4 times negative 2/3 minus 2 equals to negative 2/3 plus, what is that? Minus 4. We're here. So we're plugging in for the z here and for the z here. So what's 4 times a negative 2/3? What's 4 times a negative 2/3? Come on, quickly. Think about it as a fraction.
8 over 12.
No, negative 8 over 3. That's 4 times 2. All right, we have a couple minutes left. Minus 2 equals to negative 2/3 minus 4. So we're going to have to stop here because we only have a couple of minutes left. It is because you're dealing with fractions. I want you to look at this real quick. You do have homework. Just a quick little exit ticket, please. And we're silent during exit ticket. Grab one, put your name at the top. Hold on. Oriana, we're silent. You should have one in your hand. Name at the top. I want you to try it, see if you understood anything that we talked about today. Is that enough? Okay. Put your name at the top. Only thing you're doing is circling the solution. Put it back in the center of the table. When you are done, you put it face down in the center of the table, in the basket. But we do read it that way, we still read it that way, but still, if we have to change it, we could still change it to Z plus. Yeah. Again, name at the top, center of the table. The homework has been passed out. It should be in the center. If you have not grabbed one of those, grab one when you finish your exit ticket. You can. Okay, then. Definitely put your algebra tiles back into those Ziploc bags and put those back into the basket as well. Please. We're silent. Alright, listen up. Again, some of you have not put your algebra tiles back into the bag. Slide them in there. It'll probably be quicker. Alright, before you leave. We're silent. Naya, how do we solve for a variable? How do we solve for a variable?
If there's any holes, whatever, and
You're talking, that means you're silent.
okay, so if all of the, not the whole numbers, the smaller squares are positive, you just subtract or divide.
So what are we just doing in general? We are trying to isolate that variable. We're trying to isolate it. So it may take some steps, but we're isolating. What's another word for inverse operation, Sydney? The opposite. How do you know if you solved an equation?
Check it.
By checking it. Awesome. Let's line up. 10 seconds. 12. 5 seconds. And 0. Some of you still are not in line, so that means you're not moving quickly. Girls. Alright, y'all have a good weekend. Complete all homework. Today is Friday. Awesome. Alright, you guys have a good weekend. Alright, Kendall.
What was the answer to the second one?
The second one was 8. 8. You got it? What's your name, project? I said, because I was like, I don't think I have a grade. What is it? It's like on a moving first. What else do you use? Okay, so I was thinking that could have been a reason why. Something wasn't missing. Okay, I'll check. cards should be out on your desk and working on them down. You have 30 seconds to get your notebook out, and you are beginning on now. You are already too long. Let's go, Bell has won. Ten seconds. 5 seconds. And 0 seconds. Antonio.
Until left is
All right.
The book back. Always. This two. Check out the time. Okay.
That's our time. Okay, so looking at number 4. All right, Israel, read number 4 for us out loud, please. And everyone else, hold on, Israel, before we get started, make sure you track
Employees.
Israel. Let's make sure everyone is tracking before we get started, okay? So we're tracking Israel, we're silent. Let's pay attention. All right, Israel, go.